All right, welcome to yet another set of lesson notes that I'm hoping you will actually listen to and watch. What we want to cover today is scatter plots and linear regression. I want you to be able to write linear functions that provide a reasonable fit to data to estimate solutions and make predictions for real-world problems. The focus on this one is going to be a lot about real-world problems and also interpreting the relations between units or between stuff. We're going to look at bivariate. The vocabulary you need to know is bivariate data, scatter plot, correlation, association, line of fit, and linear interpolation. Interpolation, just because you want to say it like that. But nothing too particular crazy about that. All right, so let's look at this. Data with two variables is bivariate data. So like when we talk about looking at a real world problem, when we're talking about, say, a relationship between one and another thing, we're talking about, bivariate data when we start saying X and Y. Scatter plot shows a relationship between a set of data with two variables. So it's basically a graph. That relationship is known as a correlation or an association. Positive correlation, it goes up. A negative correlation, you can see the dots going down. When the dots look all over the place, we have no correlation. So if you look at something like this, one, what type of correlation do you see here? Well, you should be able to tell this is data that's going up, so this is a positive correlation. Okay, now, the other part here is what's the relationship between the two things? Okay, here are your wages, here are your hours. First off, you can see that the hours are your independent variable. So we're coming back to that idea. And your wages are the dependent variable. Now, we might be looking for something that says along the lines of that as you work more hours, as the hours worked increases, so do the wages, or that the wages increase. Okay, so something along those lines. Or that the wages depend upon the number of hours you work. Okay, and because of this, we could come up with what is called a line of best fit, where we do something like this, we hand draw it, and that allows us to make predictions, so that we can say, okay, let's say you work about 34 hours, you're expecting to make something about, say, $400, between $400 to $500, let's say $450 for that week, or whatever. Now, obviously, some people get to make more, some people get to make less, but you get the idea. Table below shows the population growth of the zebra mussels in a local recreational area. Identify the independent and dependent variables. Is there a relationship to the data? If so, predict the number of zebra mussels in 2039. Alright, so here's what we can do. And I'm going to explain how to do this with the calculator. Okay, so the first thing you want to do is actually create a data and statistics page, list and spreadsheets page, so that you can make a table that looks like this. Okay, and I will help you write out these steps, and you probably should have these written out before you actually have to try to, before you do this on the calculator. Then, once you've got them typed out, and notice here how we can type in what these years and muscles are, or what this what the each row stands for. In, like, say, in other calculators, you can only just, like, say L1, L2, but here we can actually type the word years and muscles for years and muscles. Okay, then you need to add another page where you get to do what is called data and statistics, where you get to actually make the scatter plot. I was getting a little tongue-tied there. So you would have something that looks like this. Okay, and then from there, we can actually go back and we can find, based on the data, not where we have to hand draw, but we can find using some number presses, where we can find, like, say, a relationship to the x and the y, and come up with an equation that would best fit this function. Okay, so then from there you can easily make a prediction based off that, and again I will show you how. So let's look at something here, and we're going to practice with this. So what you have to do is, again, we're always starting from a new document. And then once you got there, you need to add a data and statistics. I'm sorry, the first thing we need to add is a lists and spreadsheets page. Okay, when you're there, you will type in what you need to up here. You will never type into this row right here. Okay, so keep that in mind. It's always where the letters are. That's where you type in the titles, and then you type in the numbers under that starting at number 1. Okay, so once you've got, like, say, something like this typed in, years and age, you would have everything. And then once you've got all that typed in, so here I would say step 2 is type in the data. Step 3, press Control, Doc, and when you do that, it'll ask you what kind of page do you want to add, and you want to add a data and statistics page. Then you will use your cursor to set the independent and dependent variables. When you do that, you should end up with one of those, that type of graph, the scatter plot. And then you can tell me the correlation, the whatever, how one thing relates to another, that type of thing. Okay. The next part is when you start doing the linear regression part. So the next thing you would have to do is you would have to press, like, Control, and then to the left or to the right, usually to the left, but go back and forth. And when you're there, back in the list and spreadsheet, so you should be at the table. Okay, make sure you're in column C if you have something typed into A and B, and then from there what you're going to do is you're going to press Menu, number 4, Statistics, number 1, Stat Calculations. And then as far as y'all are concerned, you're going to always choose number 3, Linear Regression. Okay, when you do that, another menu thing will appear. You need to let it know what the X list is, what the Y list is, and then you can press Enter, and it will give you it will fill up all this information, and there you can get the equation of a line that will fit the data. Okay, so what we need to do is we need to practice this, and we're going to spend a couple of days practicing this, and then hopefully y'all will be able to remember this. But this is one of those, again, you need to have this paper or these notes in front of you to help you until you can do this without, say, that kind of help. Anyways, that's it for today, and I hope this will help. I hope you'll have these notes ready when I ask for them. Thank you.